Hi, I'm Snen, and I'm logging my progress as I build games with the Bevy game engine. Today's update is a little delayed. I've been working hard on trying to get online multiplayer set up for my game Cricket Pong, which I've talked about in the past two videos. It's almost done, but since it's not quite there yet, I thought I'd talk about a programming pattern that I've been using throughout the code base as a way to both sort of isolate certain aspects of how certain data types have to behave in the game logic, as well as to help code keep synchronized between client and server in sort of the right ways. Let's consider two computers participating in some online networked game, and each is going to be running our game code locally, and they're going to need to stay in sync. So that means they're going to need to transfer a lot of data back and forth, data about the current game state, as well as inputs or what have you. So what does that data look like? Well, when we have a single machine running our game, we usually track the data associated with each entity through components. So in our other case, when we're synchronizing between the two computers, that means we're going to be transferring component data for each entity, back and forth as needed based on, who's the host or who has authority over which entity or what have you. But that's a lot of data. Actually, if we were to, synchronize every single component across both instances, we'd be sending tons of packets across the network and really basically overloading the system. It'd be kind of unnecessarily much, right? So the question is, not only how do we limit the amount of data we're transferring over the network, but actually how do we hydrate each game instance with all of the data that it needs in order to sort of properly manage its internal state? I've done some of this work before on my blog. I haven't talked about my blog here yet. I have an ongoing series that has a few parts already, but isn't quite done yet. So if you're looking for a more deep technical review of how I got to some of these ideas, feel free to go look there. I'll link it below. But in the meanwhile, let's talk about blueprints. The term blueprints, the blueprints pattern, is not my own term. I'm borrowing this from another creator whose work I've read. I should be showing some of their work on screen, as well as putting some links below to the Bevy cheat book, as well as the I've Seen Tools library, which sort of introduces some of this stuff in its documentation. Actually, initially, when this is sort of referenced in that documentation, it's not even talking about netcode at all. It's talking about building sort of like scenes, right? Data types that track a whole scene's data, and then being able to keep that minimal so that you're not tracking every single component that really could be derived from some initial object, right? And that helps keep your scene files not only smaller so that it's more easily loadable, but also smaller so that it's more easily readable, more easily editable, stuff like that. So what are blueprints? Well, it's some small thing that tells you what's needed to build a bigger thing, right? You might have blueprints for a house. It doesn't contain any of the materials for the house, but it tells you what you would need and how to build it and how to put it together. Let's say we had some barrel component, and we want to spawn an entity to represent that barrel, right? But the barrel component itself doesn't have any actual data. We need to use that barrel component to spawn graphics components, maybe physics components, maybe other data types that represent whatever various features of game state we want to represent, right? And what needs to be spawned can be context specific. So let's say we're just talking about some local game where whatever, we have players spawned in a level and we're spawning our barrel. Boom, there's our barrel. And we want to attach the usual stuff, the graphics, the physics, the etc., whatever you need, right? Well, that looks a little bit different if we're going to spawn this in a server context. In that situation, we actually don't want graphics components. We probably want physics components, but there's still this whole other category of components that whether we want to add them or not depends entirely on their purpose, what they're intended to do. Now, this is also true for clients, right? When we spawn this barrel on the server side, we're going to want to transfer some data over to the client to tell it to, hey, you need to spawn a barrel too. But the components that are going to be necessary on the client side might be totally different from the ones that are necessary on the server side. So what we can do is use our barrel as our blueprint. And when we see an entity spawned with this barrel component, or when we see this barrel component attached to an entity, we know that additional information has to also be attached to that same entity that supplies it with, whatever context-dependent components are expected. Once you have that component acting as your blueprint, it's also useful then to isolate the different purposes that are going to be attached to this entity in different contexts in their own bundles. So that means, on the server side and even in local games, you might want to attach some whatever physics or game logic dependent components. You could wrap that in a specific bundle that whole bundle gets attached whenever you see your blueprint. The same thing you can do for graphics, right? You can do it for basically any isolated concern that might or might not be attached to your blueprint as a result. But using this pattern can lead to a couple of issues. There are a few really common bugs, really common kind of small problems that might be not always easy to notice, but are really important to consider as you're going through using this pattern. I've run into them several times in my own code base, and I'll kind of show you how I go about solving them in every case. So the first of these is the one frame delay problem. Let's think about our game executing along a timeline, one tick at a time, right? So we're going to have two systems, system A and system B, and those two systems are going to work together to apply our blueprints pattern and spawn our entity with all the components we're expecting to need. Keep in mind as we go forward that for performance reasons, Bevy doesn't actually immediately perform operations like spawning entities or attaching new components to existing entities. Those commands are actually buffered and then flushed at specific points in the overall system schedule. You can add it yourself. Bevy exposes this system called apply deferred, which you can just attach as needed. But just keep that in mind as we go forward. Now, in this timeline, system A is going to spawn an entity with our barrel component, and system B is going to query for recently added barrel components. That way it can, add additional stuff as needed based on the context like we described before. The problem is that this query right now won't actually detect that added barrel because the entity hasn't been spawned yet. Instead, it'll fire at a later time on the next frame after, for example, system A and whatever other systems have already run a second time. The only way to get around this is to be really deliberate about how you schedule your systems. Bevy provides a lot of tools for ordering systems relative to one another, as well as grouping them into system sets and things like that. And these are really useful and kind of critical in this case for making sure that if you have one system that depends on some other system's behavior, that they actually happen at the right times and that they respect the appropriate moments where the command queue is flushed. When you need to, you can use the apply deferred function or system that I mentioned before, but obviously you don't want to use this all over the place because, like I said before, it's the buffer exists for performance reasons, so you don't want to mitigate those performance reasons unless you have to. The other mistake that's really easy to make is inconsistency in how you use the added filter. So I haven't talked very much about the actual semantics of the query type yet. If you're not familiar with Bevy, basically what you query for is components, and that lets you iterate over entities that match that query, meaning entities that have all of the components attached that are specified by that query. So let's say we have two components, C1 and C2, and C2 is maybe our blueprint component, right? So we want to check when C2 is added in order to apply whatever other behaviors we're expecting to add. In the query I've defined here, the top part, C1 and C2, represents the actual component data that's going to get returned per entity that matches the query, whereas the second line is sort of just a filter, right? You can add whatever filters you want, and those filters are going to just be applied to check that the entity actually matches, but it's not going to change what data is returned. So this added type informs our query to filter for entities that either were just spawned with the C2 component attached or that just had the C2 component attached within the last frame. So let's again look at this timeline, right? And what happens if first we attach our C2, we spawn an entity with C2, and then on a later tick after it's been spawned, now we're going to insert C1. Well, this query isn't actually going to include that entity at any point, because at no point is it true that it has both C1 and C2 was just spawned. By the time C1 is included, we've already passed the condition where C2 is no longer added. So this is where it becomes really useful to use the OR type. It's an additional filter provided by Bevy. So what you basically want to do is make sure that either C2 or C1 has been added. It's as simple as that. And obviously there are some situations where you don't necessarily want to check that something has been added. You know, if you actually don't want to react to C1 being added, that's an important case as well. But you know, you got to be really, I guess, specific about the query filters in order to get this just right. So that's the blueprint pattern, or at least how I'm using it. I don't have the code to sort of accompany this up yet. I'm still in progress with a lot of the networking logic, and I don't want to publish anything that's incomplete just because it's not really useful to look at in its current state. But I hope to follow up with that by next week, where I also want to show some more, you know, another pattern in a sort of a similar theme. But for now, that's the end of this video. If you've watched the whole time, thank you so much. I really appreciate, you know, anybody taking the time to follow my journey. And feel free to let me know in the comments if you have any thoughts about this pattern. Do you like it? Do you think it's, you know, maybe, I don't know, whatever thoughts you might have. But yeah, if you like this, feel free to give a like, subscribe, what have you. Really appreciate you coming by, and see you next week. Thanks so much. Bye.